Hello everyone, hope you all are doing good. So here in this session, we will be basically talking about two types of pendulums. One is the simple pendulum, which you are familiar with, and the second one is a physical pendulum. Okay, so let's start with the simple pendulum. So you all know what a simple pendulum is, right? So here we have a pendulum right here, which is fixed onto a ceiling. The one end is fixed onto the ceiling, and on the other end we have a bob of mass small m, and the length of the pendulum is taken as small l. Okay, so suppose you are disturbing the pendulum, okay, that we are slightly moving it towards the side, then we know that it will start to move in a simple harmonic motion, right? It will execute simple harmonic motion since the angle is small. Okay, third, one thing that you always have to remember is that the angle should be very small, right? Okay, now let's start looking for the free body diagram of the bob at this point. Okay, say ഈ ഒരു പോയിന്റിലാണ്. അപ്പോൾ let's consider all the forces acting on it. ഇതല്ലേ ചെയ്യണ്ടേ? Okay, so the body is considered here. There is force due to gravity which is acting directly downwards, that is mg in this direction, right? And then there is tension acting in this direction, upwards, right? So we're drawing it right here. So mg downwards and tension in this direction. Okay, now we'll split mg components into two, like this. Okay, the angle theta is this one, right? So we have an mg cos theta component and an mg sin theta component, right? So the tension is equal to the value of tension force acting on the string is equal to mg cos theta. ഇവിടെ നമ്മൾ എഴുതിയിരിക്കുന്നത് അതാണ്. Okay, and the mg sin theta component is the one that tries to bring back the body. Okay, ആ ഫോഴ്സ് ആണ്, ആ റിസ്റ്റോറിംഗ് ഫോഴ്സ് ആണ് ഇവിടെ നമ്മൾ ഡിനോട്ട് ചെയ്തിരിക്കുന്ന f equal to minus mg sin theta. And since the angle is very small, നമ്മൾ ഏകദേശം less than 15 degrees ആണ് എടുക്കുന്നത്, we can write it as mg theta itself. Sin theta is almost equal to theta. Okay, all right. And when you look at this image again, I want you to look at this image again. So the bob is displaced by a length s, right? So the arc ആണ്, that is equal to L theta, right? Length into theta. Yeah, or we can write theta equal to S by L. Yeah, so let's just keep it here. Okay, and let's consider equations 2, that is f equal to m minus mg theta and s equal to L theta. And we have to put the value of theta into this equation. So what we will be obtaining is f equal to minus mg s by L. Okay, and ഇവിടെ എസ് എച്ച് എം ആണ് ബോഡി ഫോളോ ചെയ്യുന്നത് നമുക്കറിയാം. ഇറ്റ്സ് ഇൻ എ സിമ്പിൾ ഹാർമോണിക് മോഷൻ, സോ ഇറ്റ് വിൽ ഒബേ ഹൂക്സ് ലോ, ദാറ്റ് ഈസ് എഫ് ഇസ് ഈക്വൽ ടു മൈനസ് കെ എക്സ്. അങ്ങനെ ഈ രണ്ട് ഇക്വേഷൻസ് നമ്മൾ കമ്പയർ ചെയ്ത് കഴിഞ്ഞാൽ ദാറ്റ് ഈസ് വി വിൽ ഒബ്റ്റെയിൻ മൈനസ് എം ജി എസ് ബൈ എൽ ഈക്വൽ ടു മൈനസ് കെ എക്സ്. ഓക്കെ, എക്സിന്റെ അർത്ഥം എന്താ? ഡിസ്പ്ലേസ്മെന്റ് ഫ്രം ഇറ്റ്സ് ഇക്വിലിബ്രിയം പൊസിഷൻ. Okay, here it is s itself. X എന്ന് പറയുന്നത് s തന്നെയാണ്. അപ്പോൾ കെയുടെ വാല്യൂ, ഫോഴ്സ് കോൺസ്റ്റന്റിന്റെ വാല്യൂ we will obtain that as mg by L. Okay, so let's keep it there. ഇത്രയും കാര്യങ്ങൾ നമുക്ക് അവിടെ വെക്കാം. Okay, now let's get into the rotational dynamics of the simple pendulum. Okay, ഇവിടെയാണ് നമ്മൾ ഈ ചാപ്റ്ററിൽ പഠിച്ചിട്ടുള്ള കാര്യങ്ങൾ അപ്ലൈ ചെയ്യാൻ. ഇത്രയുമുള്ള കാര്യങ്ങൾ മെക്കാനിക്സിൽ ബേസിക്കലി യു നോ ഓൾ ദീസ് തിങ്സ്, റൈറ്റ്? ഇവിടെ നമ്മൾ we are going to apply whatever we have learned in the rotational dynamics. Okay, so let's find out the torque. This is something that you find out, right? നിങ്ങൾ അസൈൻമെന്റ് ചെയ്യാൻ തന്നിട്ടുണ്ടായിരുന്നു അല്ലെ, അതിനകത്ത് ടോർക്ക് ഇസ് ഈക്വൽ ടു ആർ ക്രോസ് എഫ് ആണ്, വിച്ച് ഇസ് ഈക്വൽ ടു എം ജി എൽ സൈൻ തീറ്റ, റൈറ്റ്? തീറ്റ ബീങ് ദി ആംഗിൾ ബിറ്റ്വീൻ ആർ ആൻഡ് എഫ്, റൈറ്റ്? സോ ഇവിടെ ഫോഴ്സ് എന്ന് പറയുന്നത് ഇറ്റ് ഈസ് എം ജി സൈൻ തീറ്റ. Yeah, so what we obtain is minus mgl sin theta, or again, since theta is small, it is equal to minus mgl theta. Okay, all right. And moment of inertia of the pendulum. Moment of inertia equation we have learned already, which is equal to I equal to mr square, right? So in this case, it will be ml square. Okay, and angular acceleration എന്ന് പറയുന്നത് എന്താണ്? It's the change in angular velocity, right? That is theta double dot. Theta the second derivative ആണ് angular acceleration എന്ന് പറയുന്നത്. Yeah, which we can denote with the letter alpha. Okay, I hope things are clear until this. So torque, we know the equation for torque is I alpha, right? It's equal to I alpha. Here we can apply the values of I and alpha. I being ml square and alpha being theta double dot. Yeah, but torque in the രണ്ട് values നമുക്ക് കിട്ടും. നേരത്തെ we have torque is equal to minus mgl theta. Now we have torque is equal to ml square theta double dot. Okay, ഇത് രണ്ടും compare ചെയ്യുന്ന സമയത്ത് equate ചെയ്തു കഴിഞ്ഞാൽ we can rewrite the equation like this, right? And then we can rewrite it again like this, taking the L, dividing the whole equation with L. Yeah, this is basically the equation of simple harmonic motion, right? Otherwise, we can write it as theta double dot plus omega square theta equal to 0. Omega being root of g by L. Okay. അപ്പോൾ ഇതിൻ്റെ അകത്തുനിന്ന് ഈ ഇക്വേഷൻ നമ്മൾ സോൾവ് ചെയ്ത് കഴിഞ്ഞാൽ we will obtain the value for theta as, okay, the solution for theta as a sin omega t plus b cos omega t. Okay, ഇതിനകത്ത് നമ്മൾ ടൈമിന്റെ ഇനീഷ്യൽ കണ്ടീഷൻസ് കൊടുത്തു കഴിഞ്ഞാൽ what we will be obtaining is, we can actually solve the initial conditions കൊടുത്തു കഴിഞ്ഞാൽ we will be able to solve the equation and find the values for a and b. A and b constants ആണ് ഇവിടെ. Yeah, okay. If they are to differentiate this equation, this one, that is 12, d theta by dt will be equal to theta dot, that is a omega cos omega t minus b omega sin omega t. Yeah, so by applying the initial conditions, we will be able to find out the constants. Okay, and we know that SHM in the case, the simple harmonic motion case, time period in the equation is 2 pi by m, 2 pi into root m by k, right? ഇവിടെ നമുക്ക് k യുടെ value obtained ആണ്. Remember, we got the value for k as mg by l, right? So by substituting the value here, 2 pi into root of m divided by mg by l, what we obtained is our equation for time period. This is the equation for time period in the case of a simple pendulum, right? Okay, I hope you understood the case. So now let's look into the second case, that is of physical pendulum. Okay, so the second kind of pendulum is, we're considering a physical pendulum, something like this. Okay, it can have any shape and any size, okay? So we are randomly picking up a shape, okay? And let's say it has a mass, capital M, okay? And the center of mass, let's take it as here, okay? And the distance to the center of mass, let's take it as capital R, okay? And this body is pivoted, it is fixed at this point, okay? And the body will be rotating about this particular axis. Okay, here let's find out the rotational dynamic. Let's find out the equation for SHM. Okay, let's see how it is done. So initially, we know that capital M is the mass of the pendulum, R is the position of center of mass. Okay, so if the pendulum is slightly rotated to an angle, okay, the body slightly rotated to an angle, let's say phi എന്ന് പറയുന്ന angle എടുക്കാം. Then we know that torque in the equation is R cross F, right? ഇവിടെ force എന്ന് പറയുന്നത് it's the gravitational force itself, which is mg. Okay, so R cross mg is equal to minus R mg sine phi, phi being the angle between the orbital vector mg and R, R meaning this one. Okay, here also what we can do is this can be rewritten as minus R mg phi, since the angle is very, very small. Okay, and also we have another equation for dot, which is I alpha, right? So here we can keep I as I itself, and alpha is as the double derivative of phi. Okay, angular acceleration arm. So again, equating the values of torque. Two values are given. One I alpha and another one is minus R mg phi, right? So putting back in the equation, we will be obtaining the equation of simple harmonic motion like this here, yeah, where the value of omega is obtained as root of R mg by I, yeah. And here also the solution to this equation, that is obtained as phi is equal to d sine omega t plus c cos omega t. Okay, and say the moment of inertia of a body about its center of mass, let's call it as I0. Okay, then we can write I0 equal to mk square. Yeah, ഇവിടെ ഈ ഇക്വേഷനിലെ k എന്ന് പറയുന്ന വാല്യൂവിനെയാണ് we call it as the radius of gyration. Okay, തിരിച്ചെടുത്തു കഴിഞ്ഞാൽ the value, this one will be root of I0 by n, right? അപ്പോൾ ഇതിനകത്ത് നമ്മൾ say we are applying parallel access theorem, ഇവിടെ നമ്മൾ about another point, if we have to find out the moment of inertia IA, say, then it will be equal to I0 plus m r square, r being the distance to the, that is a perpendicular distance to the axis, right? Which is equal to m k square plus r square. Yeah, here omega engane maarum, omega will be, then it will be equal to rg divided by k square plus r square. Yeah, if simple pendulum ആണ് നമ്മൾ എടുക്കുന്ന കേസ് എങ്കിൽ, one thing we know that simple pendulum center of mass is at a distance L, right? Meaning that here K will be 0. That is, K 0 എന്ന് പറയുമ്പം ഈ ഇക്വേഷനകത്ത് omega will be equal to Rg divided by R square. Yeah. The equation further നമ്മൾ എഴുതി കഴിഞ്ഞാൽ we know that is omega is equal to R and R gets cancelled is equal to G by R. Okay. So that is it about the simple pendulums and pendulums in general. That is physical pendulum and simple pendulum. So thank you for listening. Bye bye and take care.